Thank you very much, and it's a pleasure to be here with you all, and looking forward to the discussion as we go through. So, in today's session, I'm going to be talking through digital twins. What are they? How do we define them? How can we really choose how to build them in a sustainable way, and focus that on a case study around reaching net zero? To give a bit of background first, kind of who am I, why am I here? Um, David McKee, I'm the CTO and founder at Slingshot Simulations. We specialize in building digital twin solutions for net zero, for cities, mobility solutions, and so forth. However, I'm also chair at the Digital Twin Consortium, which is the leading authority globally on digital twins, working with over 200 industrial members, companies from Microsoft, Google, Dell, down to individual consultancies all across the world. So I chair the technology work and the standards work there, particularly around open source, as well as oversee all their use case work as a technical advisory member. I also lead the Responsible Computing Consortium, which is all about how we use data centers, data, IoT, all these things in a responsible way, particularly when we're thinking about SDGs and all of those. Other than that, background at various universities and working with and lecturing there. So hopefully that gives me some credence as to why I'm here and why I'm going to be sharing today, and hopefully an interesting discussion. So what we're going to look at, first of all, we're going to look at a definition of digital twins. There's a lot of definitions out there. There's a lot of questions, and I'm going to frame two definitions. One, a really simple definition, and then a more formal technical one that we can dig into. Then I will look at something that you may have come across, which is the digital twin capability periodic table. This is an incredibly powerful tool. This is a tool that we developed at the Digital Twin Consortium in conjunction with the team at Dell and another company called Xempro, looking at how you can choose and select capabilities for your use case, rather than getting into a theoretical, hypothetical discussion as to, well, how long is a piece of string? Then we'll look at best practices for building these things and really apply it with the net zero example and kind of talk through this process. This process that I'm talking through is a process that I take many of my partners through, both at Slingshot as well as the Digital Twin Consortium and with other companies that I work with. I work with a portfolio of companies and take them through this process to really accelerate that journey of adoption in a sustainable way. So what are digital twins? Here's the simple definition that I will absolutely give all the credit to my wife for coming up with, because she kept asking me, well, that you're saying 100 words and it doesn't make sense. But so how do we make it simple? So a digital twin is a digital environment that reflects on, mirrors, and evolves ahead of the real world to facilitate smart decision making and storytelling of possible futures. I'm going to highlight a couple key points here. Smart is in uppercase here because I'm referring to it using the SMART acronym. Thinking about sustainable, measurable, attainable, realistic, and time-bound. So it's all about affecting action. Insight to decisions. Because otherwise we can build the most amazing model, the most amazing tools, the most amazing machine learning, most amazing solution. But if it doesn't change the world, doesn't have an impact, there's no point. And one of the really important things for engaging with those around us, engaging with stakeholders, is storytelling. And digital twins have a really massive capability for doing so. And that's one of the things that I'm really passionate about, is using these for engaging, and particularly in the context that we're talking about today. Diving in a bit more detail, a bit more formally. Now, this definition here is the formal definition from the standards body that has been ratified by some of the world's largest companies over the last 18 months. And I had the joys of chairing that work, and I'm pretty sure I lost about 18 months of my life trying to get all the CTOs to agree. So we'll step through this sentence by sentence. There's only 4 sentences, don't worry. So a digital twin is a virtual representation of real-world entities and processes synchronized at a specified frequency and fidelity. There's an awful lot in that sentence, and the words are very specific. You'll notice that we don't talk about 3D models, we don't talk about simulation, we don't talk about an awful lot of things you'll hear in marketing about digital twins, and that's very deliberate, because each of those terminologies direct us down a certain path. Whereas actually a digital twin could be applied to a 3D model of a building, but it could be to describe the software that runs your traffic lights. It could be just used to describe how a warehouse operates. It could be used to describe a medical process. There's an awful lot of different applications for these things, but the key piece is this word synchronized, because it is only a twin when it's the twin of something. And as soon as it is no longer in sync, it is no longer a twin, which when one thinks about the linguistics of the word, that makes a lot of sense. But the specified frequency or fidelity of that could be in real time every second, but it could be once a year. It could be a human in the loop doing that synchronization, or it could be an automated system. That depends on your use case. And if it's particularly a safety case, you might not want a computer system automatically making changes. You want a human to step in and verify that. And again, going back to that previous slide, it's all about impact. It's all about affecting action, facilitating understanding, decision-making, and action. And second to that is the role of data. If a digital twin is not based on data, it could be a brilliant model, it could be a brilliant simulation, but that is all that it is. It is not realistic. It does not represent the world we live in, does not represent the system or process, and therefore it has to be based on real-time and/or historical data, so that you can then move forward and predict future. And then using that data, we can affect action moving forward. And again, emphasizing this point, it's all about motivating by outcomes. And then there's a whole lot of stuff built on data, built in IT systems. Well, you can't build a digital system without an IT system. It's fairly obvious, but you need to say these things. And I've provided the link there. There's a whole series of articles that dive into each of these sentences in extensive detail, and we'd be here for weeks going through that, which we won't do. But that hopefully gives two definitions at different levels of abstraction, a simple one and a detailed one, as to what are digital twins if you're not familiar. But then let me ask a question, which is, what is a sustainable digital twin? We've got that definition, and so what? And that's great. And this is a term that I first presented back at IoT World Congress in Barcelona in May last year, and really saying, actually, given the world we live in and the speed that things are happening, we should be using this type of technology to affect action in a positive way. We look at the UN SDGs, the Sustainable Development Goals, and we look at how we build these things in terms of the amount of data, the amount of carbon we're generating by the electricity to power the servers to run these things. And I'll give an example on that last point in terms of data. Internet of Things generates 175 zettabytes of data per year. And the amount of carbon used to store that data is more than the amount of carbon generated by the 80 smallest countries in the world. That is quite a statistic, and is painful. Every 2 terabytes of data that you and I store, which happens to be the amount of data you get for free with Dropbox or with Google Drive, etc., you would need an acre of rainforest to offset the carbon generated by storing data. So how do we build these things in a sustainable way? How do we look at renewable energy? How do we look at these different things to build these solutions? And when we're picking technologies, bearing that in mind, and particularly when we start measuring our scope 1, 2, and 3 emissions as we go through these. It's not an easy thing to do. So now let's think about actually building these things. So we've defined what they are. We're going to build these sustainably. We're going to use the best-in-class technology, and they're going to use zero carbon. Okay, that's all great. But so what? The question is what? What are we going to build? So we defined this periodic table called the Digital Twin Capability Periodic Table with our colleagues, and spent a long time working on this. And there's another layer to this in detail. And the idea behind this is that when we ask, well, what is a digital twin? You can give a definition, but that doesn't mean very much in terms of your use case. Because what we want to really know is what are the capabilities it delivers for you? What does it need to be able to do to answer your business problem and your pain? So we consider this as a toolkit where, and I'll go through an example of this in a second, where we look at different categories. There are 6 categories here where we have data services, we have integrations that we need to perform, we have intelligence, modeling, simulation, etc. We have a whole lot of management stuff in terms of security, monitoring, etc. And then we have all the user experience, 3D visualization and dashboarding and so forth. And then within each of these, for a given case study, we would expect to select anywhere between 1 and 5 capabilities from each colored section. And what that allows us to then do is to select those capabilities and say, "Now, let's pick what technologies we can use to implement that." So we're not starting from the universe of everything, we're starting from something quite small. And that really accelerates us through this process of reaching a solution. And I'll give an example. The other tool we bring to the fold with this is we provide a reference architecture. This is published, and there's a paper coming out in the next few weeks on this. This again has been ratified. We're actually seeing both Microsoft and Dell are actually adopting this, and the next slide has more detail, but I won't go through it. They're adopting this as their approach to building digital twins. And the idea behind this is so that we can say, well, what are all the building blocks? Think about Lego blocks, or what are the different blocks you need in order to build a solution, and just be able to check the box to say, do I actually have them all? What am I missing? Because it is very easy, even myself as kind of expert in the field, as a CTO building these solutions, it's very easy to miss something. And that thing that you've missed is the thing that ends up costing and end up causing the most pain as you move forward. So we see a reference architecture here that, as per the definition, runs on IT platforms, has this virtual representation at the core, which is your model and your simulation. That's the governance of it. That's the data. That's all the knowledge. And then you realize value through applications and services. And it's all about that. And the hardest bit is typically this service interface. This bit that allows us to integrate with all these different systems that are relevant to everyone, and every system that is already in place, including legacy systems. Here's it's just a snapshot. I won't go into the detail of this, but an example here of some of the things we pull out, and you can find this online, and there's a much more detailed paper that goes with this, looking at how do we actually synchronize data, or how are we actually doing this? Do we need to stream data from IoT? Do we need databases, data lakes? Do we need simulations? Do we need a modeling language? What databases do we need? How do we deploy these? These are all quite technical questions, but as we start from that business case, we dive through capabilities, very quickly you land on, and how do we do this? And this is designed as a mechanism to guide us down that approach. Again, make sure we don't miss anything as we go through. So I'm going to focus the rest of the time really on a case study to bring everything I've just said to life, because that's all great. It's all fine. We've got a digital twin. Oh, that's great. Well, let's look at a case study and apply it. So this is a piece of work that we did with our partners Electric Places, focusing on Northamptonshire Council here in England, and really helping them plan for net zero, allowing stakeholders across the council and consultants around really quickly sift through the vast number of complex and interdependent options across energy mix, building regeneration, land use, transport controls, mobility, modal shift, active mobility, renewable energy. Where do you put EV charging points? What about hydrogen? What about solar panels? And more. Even down to, well, how do we encourage people to buy local in terms of food? Because actually that has an impact on regional versus consumptive carbon emissions. So how do we look at that and bring that together for a holistic view for, in their case, their 2031 net zero plan? To do so we started and we went through an iteration here. And here I'm going to walk through this example slowly around how we selected the capabilities. And this took a couple passes. So we did a first pass, and this was the down selection of capabilities that we picked from the periodic table. We said, right, well, you have data, existing data on your current carbon emissions, traffic volumes, traffic counts, etc. That data is in disparate formats. It's all sorts. Some of it's PDF, some of it's camera data. We're going to need to transform that data and provide it context with where it's from and so forth. We then need to apply it to a model. We need to time series data, and then link that with simulations. So you can see the thinking going through here. We're not thinking about how, we're thinking about what the capabilities we need to do. And because they were logging in with Microsoft 365, a lot of this data is in SharePoint. We've got an enterprise systems integration there, and some level of system monitoring and data governance, because we need to make sure we understand who, how, when are they accessing this, and so forth. Well, actually, you want to realize value of it, so we need reports. We need to be able to simulate the traffic. There's some analysis we need to do in terms of trade-offs of different emission types, and we'll go through those in a second. We then start and predict towards 2030. So we explore that. What type of visualizations are needed? Do we need VR, 3D rendering? And these were the ones they selected. Then we went through that first process with the consultants at Electric Places. We then engaged with North Northamptonshire and found that we'd missed a few. So we then add these ones. So we said, actually underpinning this was an ontology that relates this data. How do these different data sources from land use, from traffic data, how do they relate to each other? And we'd forgotten about that. We hadn't included that within the original solution proposed for them. Well, actually, within the team, the Net Zero team, they had 5 people who were going to be collaborating on the scenarios, exploring their options, and they wanted to be able to quickly compare those notes. So we needed a way for them to online have a collaboration platform quickly to share that information. And technically, how do you orchestrate all these different simulations? Because now you've got multiple people using it. How do we manage that in the cloud in an effective way? We also, in the first pass, forgot about some of the constraints, some of the business rules. So what you can't have is 100% of people adopting electric vehicles and 100% of people adopting hydrogen, whilst 100% of people still have petrol and 100% of people have diesel cars. That sounds obvious, but actually when you're going through and you're designing these solutions, those are the small types of constraints that you forget. As was our case. On the first pass, on one of the 50 parameters we looked at, we didn't look at the business rules around, well, actually, how do you control that? Because you have to trade these off. And based on those controls, what are the prescriptive recommendations? How do we make the prediction more intelligent to account for those business rules to allow us to do things like multi-objective optimization? Now direct the thought based on cost analysis, doing a trade-off to say, actually, based on budgets, based on the impact per resident, what is the best solution? Because it isn't the solution that necessarily reduces the carbon by the most, because that's not feasible. Because we all know what we would do if we had all the money in the world. So actually bringing those trade-offs, and we proposed an equation model that actually goes through with that. Given that, we proposed a set of technologies. And I've only put a sample of these here, and excuse the long list of numbers, but I'm putting that there deliberately. So representing each of these numbers represents one of these here. And there's a whole Excel spreadsheet. There's a link you can go to. You can download this publicly. So for the simulation capability, we selected Apache Sumo because it was the cost-effective tool. Alternative solutions were 5-figure software licenses, and they didn't add any additional value. So we adopted the open source solution that supported the ASAM open standards for data exchange, and that was critical. Similar application here when it came to the VR and the 3D rendering. We benchmarked and we went with Unreal Engine because the performance and the quality was second to none. We looked at open source solution. We looked at Unity as well as a competitor. And then we looked at Slingshot Simulations' own solution. So, well, which of these capabilities do we currently have? Which, of course, was a whole load. That's why they had approached us. We would have been involved if it wasn't a whole load of. And then there was some additional development. There were some things that we couldn't find available solutions. So we worked with our colleagues at Electric Places to build some of those additional capabilities, particularly around collaboration, particularly around some of the specific dashboarding and the business rules that we didn't currently have built in, some of the things we'd forgotten. So we went through, we built those in, and we found some other open source solutions as well, and happily talk through some of those. And there's a diagram later that talks to that in a bit more detail. But so at this point, through this program, so with Electric Places, this ran over 3 months in terms of running this through to delivering a solution, and then there was a 9-month trial. And that 9-month trial, they are now 6 months into that process where they're not actively planning their next step, and we're already seeing some impact already. This is, and again, I'm not going into it, but this is an example. Now I'm entering my CTO mode. Now we're looking at the different technologies we've mentioned with Apache Sumo. I'm not cross-referencing these against the reference architecture approach as well to sanity check that. So it's now not just against the capabilities, but it's against the reference architecture. What have I missed? So we can iterate. We're looking at ontologies and can we use existing ontologies? In this case, one of the ontologies we adopted was the IFC ontology from Building Smart, which is particularly useful for building information management, which was very relevant as part of the project. We again apply the capabilities and we do this mapping again, allowing us to identify those gaps which are critical to do so. And this didn't take long to do. The whole process to get to this point was about a month in terms of back and forth engagement, and which does take a bit of time. So the result of that, and here is, you'll appreciate I can't show the actual details of the running example. So I've run the same solution, just because it shows some of the proprietary data. So I'm showing the same solution, but applying it in leads, to give you a feel for it. So this was the prototype that was demonstrated. There's videos as well online, and I will temporarily I'm going to stop sharing and reshare to make sure that any audio comes through. Actually, I'll talk over it. I think it should be fine. So what we have here is a platform. The key thing about this is that the objective was to allow stakeholders to very, very quickly optioneer, play with scenarios, quickly make decisions around what interventions do we look at for net zero. So pulling in data very quickly. In this case, this was looking at car parks. We've got heating information, types of central heating, for example, of different buildings, all published in this case from NOMIS. Pulling that all through. And then it's saying, well, actually, well, what do we want to simulate? So we want to look at the EPC data of buildings. We've got road networks as well. And you can see here, you've got the EPC ratings here of the buildings published. This was commercial properties in this particular case, but we did also do it on housing data as well. Apply this so that we can very quickly look at transition of intervention. So here what we have is, again, taking the complexity out of some of this. So we provided a set of sliders, literally, so you can dial up the intervention and play with saying, actually, if our budget allows, if the public would adopt it, we can see that if we are able to get 50% of houses to be better insulated, this is the impact. If we can see 30% adoption over the 1% we're currently at of electric vehicles, this is the impact. Play with these scenarios, and then automatically, as we adjust these, run them, and it will load some results. So quickly doing that. So we've not had to show how you configure a driving simulator. We've not had to show any of the data science. We're hiding that because the stakeholders didn't need it. And that's the key, is that actually the experts who are using this are experts in understanding their place, their city, and the challenges with solar panel adoption. They don't need to, and never should understand how to actually build a data science solution to analyze rooftops and look at traffic and how you aggregate different things in a geospatial way. It's two different problems, two different skill sets. So really kind of abstracting that, and that came out of the capabilities table of which capabilities. And some of you may, if you've seen a previous talk from myself, you'll have seen a previous version of this where we actually had workflows where you could draw the analytics process, and we moved away from that because actually the stakeholders said that is too complicated for us. Even though that was a no-code solution, I said, can we have the dials, please? Can we just have some sliders so we can quickly engage with it? And we engage then with the consultants to bring that in. In terms of the impact we see of this type of solution is that we can get a council or local authority to the point where you're down to 3 to 5 scenarios that then you take to a consultant to explore in more depth in a matter of weeks. and in some cases in a matter of days. So we're able to optioneer that down, where traditionally that would take anything between 6 and 9 months of configuring simulations, collecting data. We've done a lot of that work, and we can apply this anywhere across England and Wales. Scotland turns out is a completely different set of data in a different format. So we'll leave that one for tomorrow. But England and Wales is all fine, and this is completely automated, and pulls out a whole range of visualizations that are available. And there's a cleaner, newer version of this solution that's coming out. But this is one particular example applying that journey and that route. Oh, that's jumped. So I want to kind of pull that together. I said I talked for about 25 minutes, and really kind of the approach we take, and the approach I take, is actually, before we jump into smart solutions, before we jump into digital twins in particular, we need to use the tools that we've got available for capability selection, technology selection, we do the trade-off, which we happily support, and then look at sustainable solution delivery, ensuring that you have rapid and continuous return on investment. And that's one of the key things, is that if we deliver a solution, and often when we talk about net zero, we're talking about things that are 3, 5, 10 years out. But actually, there's benefits that we can realize within weeks. You know, there's benefits that can impact the people around us in our lives pretty quickly. And actually, that's really important, particularly when we're thinking about funding, government funding, grant funding, and also getting buy-in from the general public. It's really important that we consider that. And sometimes that means that we don't always go for the cheapest solution, but we go for maybe the second cheapest, because actually it's a more sustainable solution. And understanding that and having that upfront knowledge and understanding of that is really, really important. So I'm going to stop talking there. I think I've gone for about 27 minutes. So back to questions. I'll stop sharing so that I can see any questions in the chat.
That's brilliant. Thank you, David. Has anyone got any questions or comments? Can't see anything in the chat just yet. Isabel.
Thanks, Kiki. Yeah, I wondered, are you already working with any local authorities in Wales, David?
We are not at the moment, no.
Okay. So it's something that you're looking to explore, I guess.
Yes, and we're happy to do that in, two capacities, because it depends what stage you're at. So happy to do it in the early phases of looking at the capabilities and that planning bit, or kind of if you're further down, looking at actually supporting on the delivery on the net zero piece. So happy to kind of cross the board. And one of the things that's very important to me personally is that directing. So with my standards body hat, is I have to be neutral often and direct to some of my competitors where appropriate.
Sure. Thank you. Thanks.
Thanks, Isabel. Any other questions? So I have a question kind of leading off of that, and I'm sorry if this is kind of obvious, but you said about how the same sets of data kind of across England and Wales. So does that mean that it's like the data already exists, or do you work with other sets of data as well? Because Emma, who's also in the call, she's done a great piece of work identifying different data sets available in Wales, and like one of the main findings was that we don't use the data that we have. So I think it would be great to kind of join that up in a way.
Yes, I mean, I'd love to dive into that maybe in more detail offline as well. But I would say that we find that probably 80 to 90% of what you need, and actually maybe everything you need to get started, is already publicly available, if you know where to look.
Amazing.
The key thing is that's to get started.
Yeah.
The question is how far down a rabbit hole you go, and at some point you do hit a limit of what is publicly available. So I'll give an example when we're looking at planning for transport and mobility solutions. So we know, particularly with the new census out, we know where people live, and we know from published traffic counts roughly what is going on, but there is a limit to the level of accuracy that is at. Based on when it was collected, when it was published, there are limitations with that data. However, it can give you that first picture of, let's start here. Then we would engage with a council. So that data is public. We could start on that. We'd often engage before we even entered a formal commercial engagement. But then we'd go in engagement, for example, with Leeds. As a council, they already have the data on traffic counts. They've got 150 cameras. They've got all that data. No, it's not necessarily published, but they've got it. So now we're moving to that next level where they've already got the data. We now need to integrate it. Once we go from there, then it identifies empty gaps. You don't have that data. Right. No, that then raises the question of, do we need to go acquire it? Do we need to collect it? What does that look like? So there's a journey there, but you can start a surprising amount of cases. There are exceptions always, but you can generally start pretty quickly.
Anyone got any other questions?
I've got one quite general, actually, to be fair. Often we find it quite hard to describe to people how a digital twin differs from a computer simulation. Have you come across that problem in this context as well?
Yes. So if you remember, which I'm sure you've all memorized, that's that second slide, which says a digital twin is a virtual representation of real world entities and processes. That's all fine. But the next word is synchronized.
Yes. Yeah.
So that gives us the key differentiator there is, if I think about kind of levels, is you can have a model and a simulation. That's great. I can forecast what something will look like. It could be the best model or simulation in the world, but first of all, it's not built on real data. So actually, it can be useful. It's still got value, but it's not a twin or something because it's not been instantiated with real data. That's the first point. But then, if it's not continuously updated with data, it's out of sync. And that's where a simulation can be part of a digital twin. And I would often advocate that you may use simulations within your twin to help you make decisions based off data and so forth, but it's not the twin.
Okay. Cool. Thanks.
Thanks for clearing that, David. So we've got a question in the chat from Mark. Hi, Mark. Thanks for your question. So providing a dashboard seems straightforward, but the path from there to a digital twin, as you described, looks like a longer journey. How do you go about leading a client down that route?
So a lot of that is following the journey I described. So we start by saying what are your motivations, what are your pains and stakeholders, because if I even think about a city scale digital twin, I was first of all say stop. Say, which part of your city? Are we talking about transport? Are we talking about people movement? Are we talking about utilities? Which part of it? So that's the start. And then once we understand the objective, and it might be that there's levels of those where it says yes, it's everything. Okay, that's great, but where do we start? Once we do there, we go into the capabilities and we say, well, what are the capabilities you need? So you've got dashboards. Dashboards are one capability within that visualization part of the periodic table. What else do you need? What are the other capabilities? Where's your data coming from? Do you need simulations? And then we dive into, so every one of those 62 capabilities then has another layer underneath it, where we break those simulations into 5 types of simulation. So we can dive into that in more depth. And as we go down that, we're starting to navigate through a dialogue, and it is a dialogue, a journey which says, this is what you need your solution to look like. And you start to understand the priorities, and then you go technology selection. And the way we do technology selection is for each capability, we say, what are the best in class solutions for that capability? Independent, and we do this independent for each one. And this could be proprietary. Typically, I would look for one proprietary solution, one open source solution, and then potentially a custom build for that solution. So you at least have 3 to trade off. We then compare that against the reference architecture, and now we look at and say, do we have 20 solutions, which is too many? And then we start trading off for integration and interoperability. So we can guide down that, and that's where we're looking at cost as well. So we guide that down a path, and it's a dialogue, and we find the best partners, and we then go through there, and then it comes down to speed in terms of return on investment. How can we demonstrate return on investment as fast as possible?
Does that answer your question, Mark? It's always a bit difficult when someone's chat and you can't see them nodding. Yeah, Mark says thanks. So you mentioned cost, David. I'm guessing that's a how long is a piece of string question.
Yes. I mean, so I think I guess there's a few things to consider. So because cost could refer to really, in this case, 3 or 4 different things. There's and if kind of work backwards. There's first of all the cost of not doing it, which means all the other costs ramp up and it just gets harder. There's the cost of actually implementing the changes. The cost of building new roads, the cost of these interventions, solar panels, and so forth, and those trade-offs. And that's actually an example where you need data, and that data is not likely to be publicly available, because that is going to be down to procurement agreements at a local council level. So that's kind of a cost, and that's probably the biggest cost that needs to be accounted for. And that's easily a cost that you're going to be in the millions or hundreds of millions, depending on the scale of what you're doing. When it comes to the cost at Slingshot Simulations in terms of software, we're down typically around for a year license, and it's all bounded by region, geography, and it's not set. This is not a sales talk, but we typically are talking around the 20 to 30,000 for a license. That's roughly where we're talking. Obviously, it's an engagement, and we engage, and obviously the sale commercial team will lead on that. And then the final cost, coming kind of at the beginning of the process, is more the consultative piece, which is where I tend to live. So that's actually scope this out. What is the complexity of what you're trying to build? What's that journey? And that's where you're either onto a fixed term project, or you're on a day rate consulting piece. So that's how I tend to work, and I'll give an example. So I did one recently where I did it as a fixed price. I did it for 5,000 on a fixed price, and just because I came in on a day a month for a year. And I kind of did it at that, but there's other cases which are much higher and lower.
Great, thank you. Does anyone have any other questions?
Sorry, so was that about 125,000 for a year's long consultation? Sorry.
So I did no, it'd be a lot less.
Okay, sorry, I think I misheard you. Yeah.
No. I mean, I wouldn't say no. But no, I mean, I've done typically I would operate. I mean, for example, operate around a £750 day rate as an example, and that's typically I mean, actually, and that's probably a fairly good example of a digital twin day rate for consultants. Typically lands around that. But of course, these things, you look at the project in its whole, and you say, right, actually, is this going to be a day a month over a year, or is it going to be, what is it? And it's all economy of scale. If you need to bring a consultant in for just 2 days and that's going to be it, then you'll end up paying more per day than if you look at it. And that's just the way these things will work out. I did one. I did £5,000, where it was I did it over a year at 1 day a month. So slightly better than the 125.
Yeah.
But there's a variation. I mean, I know with others with I'd say they typically land between 3 and 20,000, depend for the consultative piece is a typical where it lands. And then that leads you down a particular solution. But it is how long is a piece of string. So take that with a bucket of salt.
Oh, thank you.
I have a question that I think someone who couldn't join the call would have asked. Have you done any pieces of work around tourism at all?
We haven't, but I guess it kind of depends on what's involved in that. You know, I'd be happy to explore that and have the conversation.
Okay, great. Any other questions at all? I think that means you've done a pretty good job of covering everything. And will you be able to send the slides over so I can share them with everyone? I think there's quite a lot to process.
Yeah, and happy to share those. And there's also a couple of links within those for some of the more detailed content, so you can go and read those at length if you so desire.
Yeah, there's loads of great resources on your website. I've already been sharing some of those. Okay, well, if there's no other questions, sorry, what's that? Oh, Max, it was really insightful talk. Thanks very much. Love the periodic table and overall approach.
Yeah, and just saying, anybody feel free to reach out to me. I put a QR code to my LinkedIn profile at the end of the presentation, so feel free to reach out, and happy to point people in the right direction as well. Generally speaking, if we don't have the right solution, I should know who does.
Thanks. Isabel says thank you, very helpful as well.
Brilliant. Thank you. It's been a pleasure.
Well, thank you very much. Thank you all for joining us.
Cheers.
Thanks again, David.
Thanks. Bye.
Take care, everyone. Bye.